Hello everyone, this is Dr. Lennon, and we're going to talk about solving quadratic equations in this section. So there's going to be about 3 strategies to solving them. So let's write down what those are. And we use some of them just in terms of efficiency and because they pop up in other places. So the first of these would be factoring. Usually when you can factor, it's going to be the quickest way. So there's 2 cases here when it comes to factoring these polynomials. One is very, very quick and the other one is just a bit longer. So I'll show the factoring by grouping method. And then the second way we're going to learn is we're going to look at completing the square. And I'm just going to do that to show you essentially how we come to the quadratic formula. So I'm not going to do the full proof of the quadratic formula, but the quadratic formula is something that you can always organize your equation in a standard way and then just plug in everything and get the right answer. So a lot of people, once they start using the quadratic formula, that's all they use. But let's go ahead and go through all the methods because they will come up in other ways. So let's first start by looking at factoring. So if you have a quadratic equation, that's a degree 2 equation. So we're looking at something that looks like ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and x is your variable. So the easy case, so the case A is when the coefficient of x squared is equal to 1, so that a is equal to 1. So this is what I would call the easy case. So when this is the case, that's all you have to do is essentially look at the constant term and find 2 numbers that multiply to it that add to the middle number. So let's go ahead and look at 2 examples of this. So we're just trying to solve for x here. So in doing so, let's go ahead and say this is part A as well. So to make this less confusing, the way I've split the cases, let's call this capital A. So I'm using a lot of A's. But this first example we want is, let's say, x squared plus 5x plus 6 equals 0. So because there's no number in front of the x squared, that's why this is the easy case. And that's all we have to do is look at that number 6, and we're trying to find 2 numbers that multiply to 6, but we want them to also add up to this middle number 5. So that's the case 2 and 3. 2 times 3 is 6, but 2 plus 3 equals 5. So if you can do this, that's what allows us to factor it. And it factors exactly as we might think. X plus 2 times x plus 3 equals 0. And then we know if 2 things multiply to 0, then one of them has to be 0. So we can split this now into 2 equations and say x plus 2 equals 0 or x plus 3 equals 0. And we get our 2 answers, x equals -2 or x equals -3, subtracting 2 or subtracting in the first equation and then subtracting 3 in the second equation. So those are your 2 answers. Okay, so really not so bad. It is the easy case. B, let's look at, say, x squared minus 4x equals 21. So what we want to do is we want to make sure before we start trying to factor, we have everything on one side of the equation. So I'm going to start by subtracting 21. So now we have all the numbers on the left, and we just have 0 on the right. And now what we're doing is we're doing the same thing. Again, there's no number in front of the x squared. So we want to look at the last number, which this time turns out to be -21. And since it's a negative, when we pick 2 numbers that multiply to it, one should be positive and one should be negative. So trying to get them to add up to 4, notice that it's going to be some combination of 3 and 7. We just have to pick the correct one to be negative. Excuse me. So the correct way would be 3 and -7. So 3 minus 7 is -4, but 3 times -7 is -21. So that's how we factor here. X plus 3 times x minus 7. And then just split up the two equations. So we get x plus 3 equals 0, or x minus 7 equals 0. And then we solve both of those. Again, subtracting 3 in the first equation yields x equals -3, and in the second equation we're going to add 7, so we get x equals positive 7. So those are the two solutions here. So that's factoring in the easy case. So let's look at the second possibility. So the second possibility, B, is the front number is not equal to 1. So this is the harder case, which we're still going to do something similar, but we're going to have to involve now a couple more steps. So what this is called factoring by grouping that we use here. So let's just go through a couple examples to show you how it works. So again, we just want to solve for x, but you'll notice now in this first one, we have 6x squared minus x minus 12 equals 0. So now we don't just look at the -12. So the reason it's the harder case is because the 6 is in front of that x squared. So we can't use the same method as the easy case. The method that works, though, is we take the 6 and we multiply it with a -12. So we get -72. We multiply the number in front of x squared with the constant term. So now we need two numbers that multiply to -72, but add up to that middle number in front of the x, which is just -1. So the numbers that work are going to be 8 and -9. So that's because 8 times -9 is -72, and if you add them, you get -1. And the trick we're going to use is we're going to say, well, notice that 8x minus 9x is the same thing as minus x. So we're going to take the minus x in the equation and replace it with 8x minus 9x, so we can split the four terms into two groups. So we have 6x squared plus 8x minus 9x minus 12. Okay, so our two groups, our first group is 6x squared plus the 8x, and our second group is the minus 9x minus 12. So what we want to do is we want to take out the greatest common factor from each pair. So if we're looking at 6x squared plus 8x, we can take out a 2x, and we'll be left with 3x plus 4. And now looking at the second pair, minus 9x minus 12, we also want to take out the greatest common factor, and we want it so what's in parentheses matches the 3x plus 4, so we're going to take out a minus 3, and we're left with exactly 3x plus 4. You can check that that's correct by distributing back over the parentheses to make sure that you recover the same thing that's above. So now, in fact, the thing that we have in common to each group is that 3x plus 4 in parentheses. So we can, in effect, factor that out, and we'll be left with 2x minus 3 times 3x plus 4 equals 0. And then we just solve both of those equations. So set each one equal to 0, 2x minus 3 equals 0, or 3x plus 4 equals 0. And we solve them. So both of them are two steps. Just add the constant term. So we're adding 3. So we get 2x equals 3, and then divide by 2. So we get x equals 3 over 2. So that's one of our solutions. Or in this second one, we want to subtract 4. So we have 3x equals minus 4, divide by 3, and we have x equals minus 4/3. So that's the second solution. All right, so a couple more steps there, but the same type of procedure. So let's go ahead and do another one for practice, see if it sinks in. So let's solve 2x squared equals 5x plus 3. Now, the same thing as before, we can't start using these factoring techniques until everything is on one side of the equation. So to do that, I'm going to move the 5x and the 3 to the left. So I'm going to subtract 5x and subtract 3 and do it on both sides. So we have 2x squared minus 5x minus 3 equals 0. And we go through the same procedure. So we start by multiplying the first number with the last number. So 2 times -3 is -6. and we want two numbers that multiply to -6 but add up to -5. So that's actually just -6 and 1. So again, what we're going to do is we're going to say -6x plus x is equal to -5x, and we're going to replace that in the equation that we had. So we have 2x squared minus 6x plus x minus 3 equals 0, and then we factor by grouping. So the first pair, 2x squared minus 6x, we can take out a 2x. So when we take out the 2x, we're left with x minus 3. And now the second pair already looks like x minus 3. So if there's nothing to take out, you can always take out a 1 because multiplying by 1 doesn't change anything. So we get 1 times x minus 3, and that gives us our factors now. It'll factor into the numbers in front, 2x plus 1 times that common parenthetical term of x minus 3. And then what we want to do is just set each one equal to 0 and solve. So we have 2x plus 1 equals 0, or x minus 3 equals 0. So for this equation, we want to subtract 1 and then divide by 2. So subtracting 1, we have 2x equals minus 1, and divide by 2, we get our first answer of -1/2. So x equals -1/2. And then the second equation is quicker. We just need to add 3. So x equals 3 is the second solution for this example. Okay, so that's it for factoring pretty much. So now let's talk about the second method, completing the square. So completing the square comes from a pretty interesting idea that actually involves factoring. So the idea here is if you have some term that, say, maybe looks like x squared plus bx, where b is just a regular coefficient, if we add a term to it, it will factor into an identical thing that is squared, so a binomial square. So what you have to add is b over 2 quantity squared, and then this factors in exactly x plus b over 2 quantity squared. And you can check that by expanding the right-hand side. If you take the right-hand side and then FOIL everything out, you'll have x squared plus bx plus b over 2 quantity squared. So how are we going to leverage that? Well, let's go ahead and just work through a couple of examples. Again, maybe you won't use this method that much, but it's still good to see. Pretty much most of the time when you see a quadratic equation, you're either going to factor it or apply the quadratic formula, but it's still nice to see this. So we just want to solve for x. So how do we do that? We need an example, so let's start with x squared minus 8x plus 1 equals 0. And notice the coefficient of x squared is 1, so if it factored, we would be able to look at the last number, which is just 1, and be able to split it into two numbers that add to -8, and we see quickly that that's not possible. So what we're going to do is we're going to take the x squared plus minus 8x, and we're going to move the 1 to the other side. So now we have x squared minus 8x equals -1. Okay, so now we're going to use that completing the square trick, and that completing the square trick, what we want to do is we want to add that special number, that b over 2 quantity squared, to the left-hand side and the right-hand side, but we want to do it so that the left-hand side will factor perfectly. So what we're adding is we're adding essentially half of -8, so that's -4, and then squaring it, and we're doing that to both sides, because whatever you do to one side of the equation, you have to do to the other. So this leaves us with x squared minus 8x plus 16 equals 15. Okay, well, now we know that the left-hand side will factor into a perfect binomial square, and that perfect binomial square is x minus 4 quantity squared. Well, if we know something squared equals 15, that means it either has to be the square root of 15 or the negative square root of 15. So that's where our answers come from. So basically x minus 4 has to equal plus or minus the square root of 15. And then we just have to add 4 to both sides, and we get our answer. So x has to be 4 plus or minus the square root of 15. So those are the two answers according to completing the square. And you can approximate them, right? One number is 4 plus the square root of 15, and the other number is 4 minus the square root of 15. You could use a calculator to get an approximation if you want. Let's do another one just for practice. So x squared plus 6x minus 2 equals 0. So first step, move the 2 to the right-hand side by adding 2. So we have x squared plus 6x equals 2. And then we want to figure out that special number to add. So it's half of 6 squared. So that's what we're doing. So plus 6 over 2 quantity squared. And that will equal 2 plus 6 over 2 quantity squared. So x squared plus 6x plus 9 will equal 2 plus 9, which is 11. And we know that the left-hand side has to factor. So that factors into exactly x plus 3 quantity squared. That will equal 11. So we end up with x plus 3 is equal to plus or minus the square root of 11. And then you just want to subtract 3 from both sides. So we get our two answers. So x is negative 3 plus or minus the square root of 11. And that's it. So these answers might seem a little bit similar to what you've seen if you've done the quadratic formula before. Where does the quadratic formula come from? So this is this last section. So there is a formula to solve all of these quadratic equations. And the quadratic formula says the solutions to the equation ax squared plus bx plus c equals 0. So again, it's important to remember that for any of these techniques, we always want to put all of our stuff, any of our numbers or variables on the left-hand side and keep 0 on the other side of the equation. But the solutions are x equals negative b plus or minus the square root of b squared minus 4ac with everything being divided by 2a. Now, usually people get tripped up with some negatives involved. The two problem areas are the negative b in front and the b squared. So if b happens to be a negative number, then the negative will still apply. So the opposite, if you have two negatives, that would turn out to be positive. And similarly with the squared, if you were squaring a negative, you want to be sure to put it in parentheses. Okay, so where does the quadratic formula really come from? Well, if you take ax squared plus bx plus c and you apply the completing the square method to it, you will get exactly this answer right here, this formula that we've seen below. So that's why the completing the square formula or the completing the square method is important. It actually gives rise to the quadratic formula. Once you know the quadratic formula and have it memorized, though, it's really just plug and chug from there. So let's look at some examples where we make use of it. So again, we want to solve for x. Excuse me. So the first one here we have 3x squared plus 6x minus 5 equals 0. So let's identify who's who. So in this case, a is 3, b is 6, and c is negative 5. So let's go ahead and jump to the quadratic formula. We end up with negative b, so negative 6, plus or minus the square root of 6 squared minus 4 times 3 times negative 5. So notice there's two negatives here. So when we multiply this out, we're going to get 6 squared plus this quantity. And then everything is being divided by 2 times 3. So let's just go ahead and simplify. So we end up with negative 6 plus or minus the square root of 36 plus 60 over 6. and we can simplify a bit more. X here is going to be minus 6 plus or minus the square root of 96 over 6. And I think typically you can stop there. Depends on the homework. Sometimes they might ask for simple radical form. If they do, let's see, 96 we know is 12 times 8, which would also be 16 times 6. Yeah, so that's probably the easiest way to do it. So here, if we think about that, we have minus 6 plus or minus the square root of 16 times 6. And the reason we want to think about it like that is 16 is a perfect square, so we can take a 4 out of the square root. So x would be minus 6 plus or minus 4 radical 6 over 6. And then, sorry, I meant to write a 6 on the bottom. And then that 6, right, we can simplify the fractions a bit. So this would be negative 1 plus or minus, and then 4 over 6 would become 2/3. So we just get 2 square root of 6 over 3. And those would be our final two answers there using the quadratic formula. So again, you can take the simplification pretty far, but really once we got to the third step, we were done. Okay, let's go ahead and do one more practice example here. So we have 10x squared minus 16x plus 5 equals 0. So again, here A is going to be 10, B is going to be minus 16, and C is going to be 5. So we can jump right into the quadratic equation. That means x has to be the opposite of negative 16 now is going to be positive 16. So here negative b turns out to be positive 16 plus or minus the square root. And then b squared, this is where I said since b is negative, we want to put it in parentheses before squaring it. And then we want to do minus 4 times 10 times 5, with everything being divided by 2 times our front number 10. Okay, so let's go ahead and simplify. So x here is going to be 16 plus or minus the square root of 256 minus, so that's 20 times 10, 200 over 20. So we get x equals 16 plus or minus the square root of 56 over 20. Again, I'm fine if you stop there, but if you do want to simplify it under the radical, let's go ahead and do that just for practice. So we get 16 plus or minus. The biggest square root that I think is in there is 4, so that's going to be 4 times 14 over 20. So this is going to be 16 plus or minus 2 square root 14 over 20, and then we can simplify a bit. All of those numbers are divisible by 2, so we can take out a 2 on the top and on the bottom, so we get 8 plus or minus the square root of 14 over 10. You could simplify the front one to 4/5 as well, but I'm not going to do that. I'm just going to leave it like this. So that's it. So you've got 3 techniques now for solving these quadratic equations. One final word. So let's think about a question. So what types of solutions are possible? So the types of solutions are based actually all on the square root part. So the answer is there are three possibilities. And they're all based on the quantity b squared minus 4ac, which we call the discriminant. So let's run through the 3 possibilities, just so you can look at, if you know the value of the discriminant, you know what they're going to be. So if b squared minus 4ac is positive, if it's greater than 0, we have two real solutions. If b squared minus 4ac is exactly equal to 0, we have only one real solution. And lastly, if b squared minus 4ac is negative, less than 0, we have no real solutions. But if you deal with complex numbers, there are some solutions. There are two imaginary solutions. So we may talk about those a little bit later in the semester. But that's pretty much it when it comes down to quadratic equations. You have several techniques to solve them. Usually factoring is the quickest. If not, I would say go to the quadratic formula. And you can always look at the discriminant to see what types of solutions you're going to have. So this is Dr. Lennon signing off.